This is proof number 12 from the Chapter 3 review. Let's take a look at it. Notice that they're giving me segment AD congruent to BC. So we've got those two segments there congruent. We're also told that angle DAB is congruent to angle CBA, which are those two lower angles there, okay? And they want us to prove that triangle ABE, which is this little triangle here at the bottom, they want us to prove that that triangle is isosceles. So first of all, think about the ways of proving triangles isosceles. You've got two very straightforward options. You can prove two congruent sides, or you can prove two congruent angles. And so, not really sure yet. Now be careful, we don't know that these two angles are congruent because these marked angles are going outside of the angles of those triangles, okay? Most of these proofs have involved triangle congruence of some kind because we can get congruent sides or congruent angles with congruent triangles. And I'm noticing these two sides and those two angles are angles of these overlapping triangles, and they look like they're congruent, and I think I can prove them congruent. So I'm going to try to do that. If you notice the two overlapping triangles, and by the way, I often encourage people to draw one of the two triangles at least so you can kind of look at the labelings. So I'll draw DAB here. You probably shouldn't normally draw it in your two-column proof, but anyway, I've got a little bit of space here. We know that this is congruent. We know that that's congruent. So we're one step short of having the two triangles congruent. Notice the two triangles share that base side, okay? AB is congruent to itself. That's a reflexive property case. And that's going to be enough information to prove my two triangles congruent, because now I have that, which is going to give me that segment right there. Notice I've got a side angle side congruence at this point. So they gave me a pair of sides, they gave me a pair of angles, and I just proved another pair of sides. So we can go ahead and say that those two overlapping triangles are congruent. We can say the triangle DAB is congruent to triangle CBA, and that is by the side angle side rule. And so some of you are probably looking at this saying, well, okay, that's great, but the proof didn't say to prove any triangles congruent. It said to prove that this triangle here is an isosceles triangle, okay? But remember, once you prove triangles congruent, you know that all of their sides and angles are congruent, and we can apply that. So if you start looking at those triangles, that means, for example, that this segment here is congruent to that segment there. But unfortunately, those segments go outside of the triangle that we're trying to prove is isosceles, so that's not very helpful. It tells me that this angle up here is congruent to that angle up there, also not very helpful. But it tells me one other thing. It tells me that this angle here, this little angle B down here, is congruent to the little angle on this side of the triangle. That angle over there, over by vertex A. And if you notice, those smaller angles are the lower angles of the triangle we're trying to prove isosceles, and two congruent angles tells you that you have an isosceles triangle. So all I need to say is that angle CAB is congruent to angle DBA, because corresponding parts of congruent triangles are congruent. And that gives me a triangle with two congruent angles. So triangle ABE is isosceles because if a triangle has two congruent angles, then it is isosceles. And that's all we have to do.